Hi everyone, my name is Riley, and today we're going to be going over the um, lecture highlights from the assignment. So we'll start with a little overview here so we see where we're heading. Um, we're first going to cover the basics of mean and median and their differences, uh, as well as the standard deviation and variance. And we'll sort of see how those four things sort of tie together um, very nicely. And then finally, we're going to cover box plots, which is sort of a way of um, understanding how, uh, sort of a way of summarizing distributions. So, to begin, the mean is just the average of a set of data. So, say we have a sample X, then the mean of that sample would be noted as X bar. So that's what this is. And then the population mean is denoted mu sub X. So basically the mu is denoting the mean and X is just saying the mean of this set of things. Um, so this is the sample mean calculation. So it's just the arithmetic mean of each data point up to the nth data point all over the n number of data points. We only really are are asked to find the sample mean of a data set because this mu sub x is difficult to find. It's like a yeah. Um, and then the median is the value that 50% of the data falls under. If there's an odd number of data points, we just take the middle point of the data. So if we have uh, 5 data points, then the median is just that third data point as long as the data points are in ascending or descending order. If there's an even number of data points, we've got to take the average of the middle two values again, making sure that everything is sorted in ascending or descending order. And this, as opposed to the mean, which measures the average of a set of data, this measures the central value. So like um, where the exact middle of the um, data is. So let's consider an example where we can work with both mean and median. So the owner of a food truck is trying to determine some statistics about the number of sandwiches that they sell. Yesterday, the number of sandwiches they sold to each customer was 2, 2, 3, 3, 4, 2, 4, 2, 4. So I'm going to ask, how would they calculate the average number of sandwiches sold per customer, as well as the median number of sandwiches sold per customer? And so to find the mean, we just use the formula that we saw previously. So it's the arithmetic average of those 9 values. So we'll take the sum of all the values in the data set. So summing up the total number of sandwiches that were sold, not just per order, and then divide that by the total number of orders or data points that we had. And then this gives a value of 2.89. So when reporting the answer, we're going to report it um, uh, with units. So the average number of sandwiches per order sold yesterday was 2.89 sandwiches. And then as far as median goes, we have an odd number of data points. So we're just looking to order the data and put it find that fifth data point. So if we put it in order and find that fifth data point, we see that the median in this case is 3. Now, something sort of maybe peculiar about this is that neither of these values are representing the most common value um, in the data set. Like um, the mean nor the median are the most common in the data set. So this is typically referred to as the mode. So we see that there's 4 2s, 2 3s, and 3 4s. So that's how we would find that. Um, but it's just interesting because, 2 is the most common, but it never came up in our calculation of mean or median. And that's because the mean um, is easily affected by outlying data, as well as the median, which um, if there's a large skew, then can be affected one way or the other. So next, we're going to cover the standard deviation. So this is the average amount that each data point differs from the mean. Again, using that same sample, big X, we use sigma sub X as the denotion of sample standard deviation, while the sigma here, the little sigma with no X, is the population standard deviation, which again is, we're not going to be finding that. So this is the formula for the sample standard deviation. So we're taking the sum here from 1 to n, subscript through this I. So we're just taking each data point. So x1 minus the mean, x2 minus the mean, x3 minus the mean. We're doing all of those each time we're squaring it and then adding it to the sum. So we're summing over the square of all the differences between the data in the sample mean. And we put that over n minus 1. So in this way, it's maybe not a true average, but the reason we have the n minus 1 is that in order to find the standard deviation, we are using 1 degree of freedom. So basically, if you think about it this way, if we had one data point, our uncertainty in that measurement would be infinite. But if we had 2 data points, so we had 2 here, 1 there, gets rid of the denominator, and basically we're just looking at the like deviation between 2 points and their mean. So that's why we use the n minus 1. Now then, the variance is the squared average amount that each data point differs from the mean. And that's, somewhat obviously denoted by this square there. So basically the same notation, except for variance is sort of the squared sigma squared. And again, this formula is exactly the same, with the exception of the square root being in standard deviation, but not with variance. So consider the food truck example. So let's say there's those number of food or sandwiches sold per order with a mean of 2.89. We can use the formula from the previous slide to find the average spread in the data set as, or the standard deviation as, 0.93 sandwiches per order. And for variance, we can just square this value, since that's how you go from standard deviation to variance. So the only difference here after squaring is that we have to square the units that we have. So we're working with 0.86 sandwiches per order squared as our variance. So this is sort of bringing it all together so we can see in these two pictures, mean, median, standard deviation, sort of how those interact when there's a skewed distribution, symmetric, their mean, median, mode are all the same. And you can see in this first picture that standard deviation sort of is used to scale the distribution. So basically saying how far is our data going to be from the mean. So a box plot is a type of graph that helps us better understand the distribution of data. So these plots summarize things like the minimum, maximum, medium, lower quartile. So the point that 25% of the data falls under, in the upper quartile. So the point that 75% of the data falls under. So in addition, these plots give us some idea about spread and skewness. So here's a picture of a box plot. So we can see first 25% of the data is contained in this first sort of bin, second 25% in this bin, third, fourth, with the middle sort of box part of it containing 50% of data. In the median being this center line. So we always label our box plots. They can be either horizontal or vertical, but these units here are quantitative or numeric, and we want to show like quantitatively where are these, what value do these box plots, what value do these Q1, Q3 median, minimum, maximum have. Oh, it's worth noting as well that we have no idea how large the sample is. We're only given, these values, the 5 values that are on the screen. So we have absolutely no idea the sample size, I guess, if you will. So in summary, we use the mean to measure the average of a set of data, the median to show the center, standard deviation to show the average amount that each data differs from the mean, variance measures squared average that each data point differs from the mean, and a box plot to summarize distribution statistics. Thank you.